We would like to find all values of the complex logarithm shown here, the log of I minus 1. So first let's recall the definition of the log of a complex number. The log of z is equal to the natural log of the modulus of z plus I times arg of z, where the arg of z is the set of all possible angular representations in the polar form of the number z. So in our case, I minus 1 is our complex number here, and that's the same as negative 1 plus I, which is in the second quadrant. There's negative 1 plus I, and one argument for this complex number is 90 plus 45 is 135 degrees, or 3 pi over 4 radians, which is the unit we'll use. So the log of I minus 1, or negative 1 plus I, is the natural log of the modulus of the complex number plus I times the arg of the complex number. Now the modulus of the complex number is the square root of 2. And then the argument is, one argument is 3 pi over 4. And then there's infinitely many arguments, because you can add any multiple of 2 pi to a given argument. So this is an answer, and the log of the square root of 2 can be rewritten as 1/2 log 2 using a property of logarithms. K is an integer. The property of logarithms is the logarithm of x to the n is n times the log of x. The square root of 2, of course, has a 1/2 power, and that power can be brought to the front. So the log of I minus 1, the complex logarithm, it's multi-valued. There are infinitely many values of a complex logarithm because there are infinitely many arguments. The real part is just a constant. It's the natural logarithm of the modulus of the complex number. So there's just one number for the real part, but the imaginary part involves the argument of the complex number, and there are infinitely many angles that are coterminal, and so there are infinitely many arguments to be considered, and therefore there are infinitely many values to the complex logarithm.